Hello everybody. We're going to go over AP number 9. AP number 9 says, let f be a differentiable function defined for all real numbers x with the following properties. Now the first property tells us about the derivative function. The second property tells us the first and second derivatives at particular points. And the third property tells us about the definite integral of this function. So we have to find f of x given this information. So let's just think about this. F of x is equal to the integral of its derivative. And remember, every time we integrate a derivative, they cancel. Well, that's equal to the integral of ax squared plus bx with respect to x by property number 1. But if we integrate this, we get a times x cubed over 3 plus b times x squared over 2 plus a constant. So this is our f of x, except that we have 3 unknown variables. We've got the a, we've got the b, and we've got the c. So in order to get the function, we first have to figure out what these values are. So let's just backtrack a little bit and go back to our first derivative again, which is ax squared plus bx. And by property number 2, we know that the first derivative at 1 is 6. So let's put in 1 for x, and we get that the first derivative at 1 is equal to a times 1 squared plus b times 1, which just gives us a plus b, and that equals 6. So in order to solve for a and b, we need another equation with a and b in it to solve for it. So let's use the second derivative. Well, the second derivative at 1 is 18. And the second derivative at x would be 2ax plus b if we use the power rule here on the first derivative. So doing something similar to what we've done before, we'll substitute 1 for every x in the second derivative. So this implies that the second derivative at 1 is 2a times 1 plus b. That's 2a plus b, and that's equal to 18. So for these conditions to hold, these two equations must hold. So let's solve for a and b by solving the system of simultaneous equations. So let's take those two on the side. A plus b equals 6. 2a plus b equals 18. And let's subtract. So we'll subtract the top from the bottom. So 2a minus a is a, b minus b is 0, and 18 minus 6 is 12. So a equals 12, and since a plus b is 6, this implies that b must equal negative 6. So we've got the two values of a and b that we could put into our first derivative. The only thing that's missing is the plus c. So let's take a look at the first derivative again. Now, the first derivative becomes a, which is 12, times x cubed over 3, plus b, which is negative 6, times x squared over 2, plus c. Now we're substituting these values in here. If we go up, 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 over here. Okay, so I substituted my a, my b, but I don't know c yet. So let's simplify this. We get the first derivative of x is equal to 4x cubed minus 3x squared plus c. We shouldn't overlook the c because we have to solve for it. we've exhausted all our information. We use the first derivative at 1, which is 6. We use the second derivative at 1, which is 18. We use that the first derivative is ax squared plus bx by integrating it. So the only thing that's left is the definite integral. So, oh, wait, excuse me. I made a mistake here. This is f of x. So let's just erase that, and I'll correct it now. So this is f, oops, I've got to get my pen. So this is f of x, and this is f of x. I wrote the wrong notation. So what we will do is we're going to integrate f of x. And because we have f of x and there's a c, let's just go with it. And we know something about the definite integral of f of x from 1 to 2, and that's equal to 18. So let's evaluate the definite integral of f of x from 1 to 18. I'm going to turn to the next page now and continue. So, the integral from 1 to 2 of f of x dx is equal to the integral from 1 to 2 of 4x to the third minus 3x squared plus c with respect to x. Okay, so that gives us 4 times x to the fourth over 4 minus 3 times x cubed over 3 plus a cx. And we don't need another c because this is a definite integral from 1 to 2. And let's just simplify that a teeny bit. X to the fourth minus x cubed plus cx from 1 to 2. Now, by the first fundamental theorem, we're going to substitute 2 for x. So that's 2 to the fourth minus 2 cubed plus c times 2. Okay. And then we're going to substitute 1 for x. That's 1 to the fourth minus 1 cubed plus c times 1. So we get 16 minus 8 plus 2c. And this gives us 1 minus 1 plus c. So we get 8 plus 2c minus 0 plus c, or c. So that gives us 8 plus c. And the value of this definite integral was 18 by condition 3. So c is equal to 10, and therefore, putting it all together, f of x equals x to the fourth minus x cubed plus 10. Oh, wait, no, let's see. Wait, I missed it. Plus 10 c is 10. So it's x to the fourth. Oh, no, that's wrong. Hold on. Wait. I have to erase this. Oops. Let me go back to my eraser. Let me go back. Okay, hold on 1 second. All right, I'm going to do this again. I don't know if you can see it, but this is equal to x to the fourth minus x cubed plus cx. All right, but now we have to take care of the limits of integration from 1 to 2. And remember, the definite integral doesn't take a constant. So by the first fundamental theorem, we're going to substitute 2 for every x. And then the 1 for every x. Right? So we get 16 minus 8 plus 2c minus 1 plus c. So that gives us 8 plus 2c minus c, and that's 8 plus c. But we were given that this definite integral is equal to 18. So this whole thing is equal to 18, c equals 10. So to answer the final question, f of x equals 4x cubed minus 3x squared plus 10. And this is our final answer. I hope you'll be able to see all of this. Okay, we'll go on to the next problem very soon.